If anything fails, it's the presentation effect. It's already. All right. Yep. All right. So, hi. I will talk about, my name is René Kopeinik. I will talk about ProAV time series analysis toolbox. I'm from the Luxembourg Institute of Science and Technology. First and foremost, a short personal background about myself. I have a master in spatial information management. Actually, I'm a GIS guy. Get stuck in Earth observation science. And yeah, I was one of the first trusted testers in Google Earth Engine. And I'm kind of spatial data scientist something. And yesterday, the first presentation with the imposter syndrome, that got me thinking about sometimes when I code basically every day, and I think I'm a good programmer or I'm just really good in Stack Overflow. So yeah, just some funny stuff at the beginning. So let's start. The ProAV mission exploitation platform third-party services project is led by Space Applications in Zaventem in Belgium. There are a few collaborators, which is the Luxembourg Institute, for example, the Wageningen University, the TU Delft, that's a Boku Vienna, I guess, Progressive Systems, the University of Louvain, and Visioterra. But each of these projects are kind of independent, small projects. So, what is ProAV? Well, ProAV is basically, the V stands for vegetation. It's a small satellite providing multispectral images to study vegetation on a daily and global basis. ProAV exists in top of atmosphere and top of a canopy for 1 kilometer, 300 meters, and 100 meters resolution. Basically daily, every 5 days, and every 10 days. If you want to download the data, it's actually free to download at VITO. VITO is the Flemish Research Institute that basically is in charge of hosting the data, in charge of creating the products. So yes, but we kind of don't want to download data, isn't it? Because for what? So that's a probably image of Cairo. I think it's 100 meters, I'm not quite sure. Right, so creating the toolbox, the goals of creating the toolbox was basically to have a toolbox for univariate and multivariate time series analysis without downloading any data, because I think everyone who was working in the past with Landsat or with MODIS or whatsoever, it's kind of a pain to download everything all the time for just small analysis. We wanted to be, well, we have to be, because of ESA is our boss, so to say, OGC compliant, only using open source softwares, libraries, and packages. So the envisaged architecture, basically, I was dividing it a bit in kind of layers or something like that. On the top, you have the application layer, which is basically the user interfaces. We have a web interface. For the more expert users, we have a Jupyter Notebook. The RStudio we completely skipped because Jupyter Notebook actually also can run on our kernel, and that's it. The connectivity is done by WPS and REST services that we set up with VITO together. The processing layer basically is HPC in VITO in Belgium, actually in Flanders. Then the data storage layer basically is databases from APIs, file system, web services, whatsoever. Here we can see a data service layer. These are the available data, but well, I made this illustration quite a while ago, so these are not kind of the available data that we have right now. So here we have ProVV, all sorts of ProVV data, obviously, rainfall data, VAPAR, some Copernicus, and meteorological data from ECWMF. But this is the real data availability right now. A few of them only exist for Belgium because we're hosting the data in Belgium. Yeah. For example, this will change. I mean, not the Belgium coastal zone, but cannot move that one. But the Sentinel data, for example, Sentinel-2, NDVI, or the leaf area index, or FCAVA, or VAPAR, will be available for the whole world. All the biopar data basically are derived from ProVV and the spot VGT. And also, in order to create some meaningful content for third parties, lately I was talking at the ProVV Symposium in Ostend with people from the World Food Program, from the World Bank, Food and Agriculture Organization. So now we want to create some meaningful content in order to not only include NDVI data or like rainfall data or whatsoever, also want to include like food production data, food harvesting, whatsoever. They actually can find some nice links. Yes. So the main functionality components. So basically I decided to split the toolbox into actually 4 components, but there's a 5th one because sometimes I create algorithms and I don't know where to put them. So I just made an extra folder. So it starts from data management and processing, pre-processing basically. It's got data aggregation, like missing value inputs, outlier detection and so on. Basic statistics and trend analysis. For example, descriptive statistics, linear trend analysis, and so on. Seasonal components, then advanced multivariate analysis, and some, mixed algorithms that I didn't know where to put them, but for example, like k-means clustering or classification and stuff like that. So in what kind of programming language we are developing, that is Python and R. And here we can see some key software libraries that we are using. It's obviously because we are working with time series, so we need some kind of data frames, and so we use pandas and GeoPandas. Basically, all the analysis, the statistics are done with stats models. Yeah, and here is also two software libraries that you might don't know is the catalog client and the data client, which is from Vito, and also from us. So with that we are accessing the data. So basically the toolbox is divided into 2 different toolboxes, so to say. So we have the web interface runs totally on Python. The front end and the back end developed in Python. The toolbox itself is actually a Python package that we most likely will publish. And the R part is done basically directly on the Vito server, on the Vito notebook hub, where you can actually directly access the data and do whatever you want on them. So a small example workflow. So there's a user login for the Jupyter expert interface. Well, it's run on the notebook hub. So basically you can decide between the web interface or the Jupyter notebook interface. Let's go to the web interface. You enter your input information such as start, date, end date, image type, and functions, and then you can visualize. On the other hand, the Jupyter Notebook is a bit more flexible. You basically, if you are a Python programmer, you can basically program everything, whatever you want in Python, so to say. And yeah, we also have some tutorials, and for people who would like to start to program in Python, we also have tutorials that are easier to handle with widgets, and not to program everything on your own. And data can be exported, saved, and also shared results with, via WMS server. So this is the web interface. As you can see here, this is the first prototype of the web interface. As you can see here on the, you can draw a polygon or just set a point somewhere, and then it calculates the time series, and then you also can you also can zoom, well, and then you choose on the right hand side a function, and then you can basically also zoom in the area where you're interested in. On the below, you can see all the available imagery that exists, and these come from a web mapping service. Okay, this is, for example, this was Sentinel, sorry. This is Prova-V, this is, I think, 300 meters. And here I can see basically the same thing. And what I did here is I just applied, I just draw a polygon in the Peninsula Yucatan, and I executed a rolling mean. So yeah. The mockup for the further development of the toolbox should be like, as you have seen here on the right hand side, there's just one function to choose. It should be like this. It should be somehow an analytics chain, so that you actually can do more than one analysis, one function. On the top you can see, sorry, on the top you can see the layer. You can choose a layer that you can drop a geometry, the dates, and maybe cloud coverage. That would be quite amazing. Geometry in the moment is for this interface is only foreseen that we do point and polygon. I would love to drop a GeoJSON or whatsoever in order to work on your own geometry. In the Jupyter Notebook, I do basically the same thing. I also can here, as you can see here, I just drop the polygon, and then I can calculate the time series over this polygon. But if you're a Python programmer, you're much more flexible here to do more sophisticated analysis. So yeah, this is, for example, rolling mean, and there down is a detrended, and it's still quite visible, the trend, so detrended time series. This, for example, is an example about autocorrelation or partial autocorrelation, and below, as you cannot see anymore, is a Fourier extrapolation. So this, I also include a REMA model, and lately I was working a bit on Facebook Profit. I don't know if someone of you knows that. It's also like a prediction library. So, but yeah, this is kind of not really sexy, you know. It's like you just see a graph and that's it. Like, I cannot see, I do not really understand so much about it. So I was thinking, like, why not including, instead of only pandas, including also geopandas. So I lately also did this. This is an example of Mexico. As you can see here, what I did basically is I created well, why I choose Mexico, because it's kind of very diverse in vegetation. As you can see here, the brighter the color, the more desert, and then the darker the color, the more tropical forest, like you can see here from on the left side, Baja California, and on the top down, the Peninsula Yucatan. Obviously, it's a completely different type of vegetation. This is a shapefile of the Mexican states I chose. It's 31 polygons, but the more important thing is it's almost 2 million square kilometers. 12 Proba-V tiles are necessary to cover this surface because of the islands as well. And here the spatial resolution of this test was 100 meters, and I said, okay, from 2013 on until today, basically until the 10th of September, the 10th of July, and every 10 days. So this was quite a lot of data, and I managed basically everything from sending the request to the time series API, the backend calculating everything, until I got back the GeoJSON, the JSON, the raw data, changing it into GeoPandas. It took me around less than 5 minutes. That was quite impressive. So I guess the backend works pretty well. We also have, as I mentioned before, a R package, or like we will create an R package where you can access the Vito notebook hub, and you can basically develop in R. Here I was writing some codes in order to get the data from the server. I could not include yet. Actually, in the presentation before, we have seen some time series, time lapse, or some video. I did that also already on the real data. That works quite nice in the Jupyter notebook. This will be also available, obviously. Yeah, here's some simple monthly aggregation. So what's next? Well, next concerning towards development is to finalize, obviously, the development of the Python and the R package. The Python package is basically, I would say, 90% done. The R package, let's give it a 60%. Test and validate, obviously, and adapt for the first version of the toolbox this August. Actually, the toolbox, the web interface is already out. So it's already published, and then the final testing or the final validation when the project for us ends basically is November, December 2018. We also have, because of I mentioned before WPS, we have a collaboration going on with space applications. So we'll discuss in their ASB orchestration tool to implement the time series analysis toolbox. And also, furthermore, we have some discussions with ESA. They would love to implement or like to have somehow a link between our toolbox and the SNAP toolbox. But, well, we're trying to do that, but as if you have worked with SNAP, it's a completely different thing. This is a web application or a server-based application, and SNAP is actually a desktop application. So, and as said before, like I don't want to tell the user to download data if it's not necessary. So yeah, that's basically it. Thank you very much.
Thank you. Any question? Again, no? So I have one. You just analyze NDV data or AV data also?
Sorry?
NDVI just or
No.
AVI?
In this example?
Yes.
No,
the toolbox.
In general, oh no, yeah, it's NDVI obviously, and as you can see here, for example, leaf area index, NDVI, F-cover, VAPAR, yeah.
Okay, and you make any phenology analysis, for instance? start of the season, the end of the season for...
Exactly, yes. Also, this is basically somehow included in the data preparation. So I try to find peaks, for example, and I also try to find, as you said, the start of the season, the end of the season, and so, yeah, this is also included, definitely.
Okay, thank you. More questions? Okay.
Yeah, you can actually, in the moment the web interface is a prototype, so there is not really a lot to see. You can access it, I can give you the link. In order to access the notebook hub, you just need to sign up on the website of, on the ProV website, and then you get an access to the notebook hub. Not yet. But most likely it will be, because of it's an ESA-funded project, so it should be actually everything should be published. Well, obviously the Python package and the R package will be definitely published.
More questions? No? So thank you again for your presentation. Now we'll move for last presentation of this session, given by Andres. And the title is Alien World, 3D Maps of Celestial Bodies with VTI.